Good day, everyone. I am Jeanette Achambal of B Scream 3A. So today, we will discuss a lot of things about fire and heat transfer. So first, let's discuss what are the factors that affect the spread of fire. So the two factors that affect the spread of fire is weather and topography. Weather has three elements: the wind, temperature, and humidity. In wind, fire spread faster in the direction the wind is blowing. In temperature, fire spreads faster at high temperature. And in humidity and precipitation can slow or stop fire spread. Topography as well has three elements: the orientation, slope, and barriers. The orientation from the sun affects energy received. In slope, fire spreads faster uphill, and in barriers, fire can be impeded by barriers like water. So second, what is spontaneous combustion? So spontaneous combustion is the outbreak of fire without application of heat from an external source. Spontaneous combustion may occur when combustible matter, such as hay or coal, is stored in bulk. So third, what are the flashover, backdraft, bite back, flash fire, and differentiate heat versus temperature? So first, what is flashover? So flashover is the near simultaneous ignition of most of the directly exposed combustible material in an enclosed area. When certain organic materials are heated, they undergo thermal decomposition and release flammable gases. So the second is a backdraft. A backdraft is caused by the sudden introduction of air into a fire that has depleted most of the available oxygen in a room or building. When a fire has depleted most of its oxygen, the flames will die down, but the fuel will still burn in a smoldering state and still generate heat like with charcoal. So third, the bite back. So a bite back is a fatal condition that takes place when the fire resists extinguishment operations and becomes stronger and bigger instead. So the fourth one is a flash fire. A flash fire is a sudden intense of fire caused by ignition of a mixture of air and a dispersed flammable substance such as a solid, flammable or combustible liquid, or a flammable gas. It is characterized by high temperature, short duration, and rapidly moving flame front. So the fifth one is the difference between heat and the temperature. It is very important to understand the difference between heat and temperature involved in a fire situation. Thermal energy relates to the average energy that is stored or contained in the molecules of a material. At the molecular level, it relates to the kinetic energy of the atoms, molecules, and ions in the material. Temperature is a measure of the average kinetic energy of the particles in an object. A hotter material contains more internal energy than a colder one. Temperature is measured in degrees Celsius, Kelvin, or Fahrenheit. A thermometer contains a fluid that expands as it heats and contracts as it cools. With water, for example, as the temperature of the surrounding liquid increases within a tube moves up the scale, and the increase in temperature is measured by the amount of movement of the top surface of the liquid. Another way to look at temperature is as a measure of the degree of heat of a body or a substance. In contrast, heat is the amount of energy measured in joules. that is involved in heating the water to a higher temperature. It does this through the process of heat transfer. Heat is the amount of thermal energy that is transferred from one object to another due to a difference in temperature between the two objects. This is why it is important to estimate how much heat there is in a fire, as well as how this heat energy can be transferred into its surroundings. So let's proceed to heat transfer. What we're really talking about here is how energy moves. Heat transfer occurs really in three ways, and these include conduction, convection, and radiation. Let's take a look at each of these, starting with conduction. So conduction is heat transfer as a result of molecular contact. The best way to understand conduction is by having this example. So here, I have a metallic spoon with a candle underneath it. And now, what we know is that if we stay like this longer, the spoon will heat up, and not just the part of the spoon that is over the candle, but rather as a whole. And the reason this happens because of the conduction. Energy from the flame is causing the molecules within the spoon to vibrate, and that's transferring energy from here to here until here until the entire spoon has warmed up. That heat has transferred throughout the entire material. And let's not all forget that conduction is going to happen most effectively on solid materials. But let's not forget about convection and radiation. Let's look at convection. Convection is heat transfer through or as a result of density differences. So let's grab a match and let's think about this for a minute. I think we all know it's probably not the best idea to hold your hand above an open flame like this. And that's because a lot of the heat energy generated by that flame is going to rise. That is purely because of the process of convection. You see, what's happening is the flame is causing the air to expand, and with it expand, it becomes less dense than the surrounding air, and therefore floats upwards, and with it goes some of that heat energy. That's what convection is all about, and this is going to occur most effectively within liquids and gases. Finally, let's go to radiation. Radiation is heat transfer by wave motion. Let's pull that flame up one more time. I think we know that because of convection, heat is going to rise, but it's also going to travel outwards in the form of waves of energy, electromagnetic waves, and that's the third type of heat transfer. Radiation is really interesting in that it doesn't need a material for it to travel. So this can occur out in open empty space. In fact, this is how energy travels from Earth's sun to the surface of the Earth. And so if we look back, we have our three types of heat transfer: conduction, convection, and radiation. And it's important to know the keyword that goes with each other. For conduction, it's going to be density differences. For conduction, it's going to be contact. And for radiation, it's going to be waves. We can sum all three types of heat transfer up in one diagram by looking at something as simple as a campfire. Imagine that you are camping and you hold a pot of water or stew above that flame. Well, right now in this picture, we are seeing all three types of heat transfer take place. There's conduction happening as the flame is transferring energy directly to and throughout the pot as a result of molecular contact. Additionally, there's convection as heat from both the boiling pot and the flame itself is rising up as a result of density differences. And finally, there's radiation occurring all around the campfire as energy travels away from the flame in the form of electromagnetic waves. And that's a quick look at heat transfer.